Hello everyone, in this video we will talk about data preparation, data cleaning, the two methods of data scale down, that is data standardization and normalization, along with proper Python code. And the working of these I will also give a demo in next video probably in my Python IDE Jupyter. So let us just start. So by the end of this video, you will be able to have a good grasp over the concept of data analysis. We will see how to analyze data, raw data, and how to clean it, basically how to remove the unnecessary columns and all. So we will understand standardization along with mathematical formula and code implementation. We will understand normalization along with the same. So once we have the raw data in our hand, we need to pre-process it. What does this mean? We need to analyze the data first. Suppose we have this. Suppose there is a large data set. I am not giving the entire table. First two rows I have given in detail. Suppose white, African, and Asian. These are only the three categories, and the other columns of ethnicity also has only these categories. So the height, weight, whether it will survive till 70, and the address. So this is the raw data we have in our hand. So first you try to guess what is the value we need to predict, right? So first of all, this is classification or regression from my previous video. If you say, so we are classifying whether it will survive till 70. It is yes or no question, right? We have only two classes, so it is classification, it is not regression. The first thing which you need to understand, then you need to understand which is the first. If you understand the first thing, then you will obviously have understood the thing that this column is the column which will be used for testing purpose, right? This column we will need to predict. Suppose the AI model which we will make, we have to feed the model with ethnicity. Suppose there is some future, there is unknown row whose ethnicity, height, weight, address we give to the data, and we have to predict. The AI model will predict whether it can live till 70 or not. So that will be the main function. So this will be the y column, y axis, right? And this will be the other features, x1, x2, x3 and all. Now you carefully analyze and tell which of these columns is useless in predicting this. In predicting whether a person will live till 70 or not, which of these columns is useless? So yeah, you can see that ethnicity, it can have some use, right? Because in the genetic design, it may differ, right? Whether the person will live till 70 or not. Height and weight are physical characteristics of a person, it may be useful. But address, you see, whether a person will live till 70 or not, is it at all related to address? You see this in general sense, right? You cannot tell that the place where more explosions and keep on happening and more wars are there, the person will die early. You cannot say that, right? If you are talking in a general sense. So while talking in a general sense, you can see that this address column is useless for us. While analyzing the AI model, for the AI model, this address data is useless, so we will drop this column. First thing we say this. Now you know that ethnicity are of here three classes. You also know that machine only understand numbers, it does not understand letter. So what you will do, what you have to do something with this column also, right? So what you will do, you can replace white with 0, African with 1, Asian with 2. You do the encoding this way. You assign white equal to 0, African equal to 1, Asian equal to 2. So using pandas library, you can also do that, right? So now you understand the ethnicity, height, weight, survive till 70 or not. Yes or no, it does not, it will not understand. So let you can easily replace yes by 1 and no by 0. So we have the, now you see we don't have this column in the new data set. We don't have this column, and we are having only numbers. In all the columns we are having only numerical values. Now you see the scale of the numerical values, right? What is the scale of this? It is ranging from 0 to 2, is it not? Here it is ranging from 0 and 1, but here it is 186. So imagine plotting it in a graph, how bad it will look. Like these are the dependencies of these, right? So you cannot work with a graph, so you need to scale the data down, you need to scale everything down, so you need to bring everything under one scale. You need to do that is very important. So from this simple table, as a data scientist, you need to understand so many things, and then you will proceed with your coding. So to be noted, address is useless here as we discussed. Ethnicity needs to be encoded with 0, 1, 2. We need to do feature scale down. Feature scale down means we like it is ranges 0 to 1 and 0 to 2 and 0 to 1, and we cannot plot it with 186, 185. These are very huge values with respect to this. So we need to scale everything down. So in this video, we will understand two methods of scaling. One is standardization and the other is normalization. So feature engineering, in the sense working with these features and understanding which row, which column to is useless, is known as, this is the core aspect of data cleaning and preparation. Here we select most useful features and eliminate the useless ones. We can also combine existing features to reduce the dimensions of data. Example, length and width column can be replaced by a single area column. Suppose you are building an AI model which can predict house. Now you are seeing that the dimension of length and breadth is given of a building, right? So you don't need that. You can replace that by area in acres. So you reduce the dimension of the data in this way. You reduced one column, you remove the column width and length and replace it by single area column. So this also falls under feature engineering. You need to understand which features to eliminate without significant loss of data. So feature scaling, otherwise it will cause problem in certain algorithms. As I told you in the previous slide, standardization, standardize all the features on a standard normal distribution. This gives the characteristics of Gaussian distribution, which we will understand. And the normalization also rescales all the features between 0 and 1. So we'll just quickly go through. Is if it gives the data the property of Gaussian distribution. The mean of each feature is centered at value 0 and the feature column has a standard deviation of 1. The graph is such. So I have also told you how what is the formula of this curve in my mathematics video of Gaussian distribution. So you see what is the formula to calculate this each data. So x dash of ith observation equals to x minus x mean. This is the mean and this is the standard deviation. You just apply this to entire of your data and it will be standardized. Let's see how. So using Numpy, how can we do this? First we have a dataset X. We will have the dataset, how to import the dataset, work with it. I will show it in my IDE when I will work it in my next video. So you just know now that X is a dataset. Now we define a class matrix np.copyX. We are copying it in another matrix. Now we are selecting the matrix of this. I told you the comma, left of the comma means rows. I am selecting all the rows and the first column equals to what? I told you x minus x mean by x standard deviation. So xi, the ith data, minus dot mean. These are the functions of numpy I told you, and because I have already assigned it as a numpy array, right? So now I can use the functions of numpy over this. So I calculate the mean simply in this way, and std is the standard deviation to calculate. So here in the next we assign for the second column like this, all the rows and the second column, and so on for the other columns. This we can do standardization using manually. Now if there are a lot of columns, like lot of features are there, suppose, then what you will do, you will keep on writing this. No, you don't need to do this. So all that I said now for mathematics and all is useless if you see that yourself only as an AI developer. Why? Because don't need to remember all these. There are already predefined libraries. The ML libraries scikit-learn implements a class for standardization. So we will just simply write sklearn from sklearn.preprocessing import standard scalar. This is a class for standardization. Now we know that Python is an object oriented programming language. So we define an object stdsc is equal to standard scalar. Now we define xtrain standardized xtrain equals to stdsc dot fit transform xtrain. What is xtrain and xtest? I told you in my previous video that the data set, suppose we are having 100 rows data set, we will first divide it into 80 rows of training and 20 rows of testing. We can do it like 60-40 or 75-25. We can do it in that way. So how to do that I will show you in the other upcoming videos, but as of now you just understand that xtrain is a matrix which is the training data. So xtrain std is our standardized training data, is fit transform. Now xtd, you can also do this for the testing data. Now fit means finding the conversion logic. Once you find the conversion logic, fit underscore transform, you do not need to apply it again. The other time you can simply write transform. The function fit transform you need to apply only once, and transform for the latter parts. Suppose you divide training, testing and other parts. So the first part you did fit transform, then all the other parts you can do just simple transform. So similarly, normalization, in most cases, normalization refers to the rescaling features between 0 and 1, which is a special case of min-max scaling. This is the given formula. And to be noted, we must apply the same rescaling technique to every column of the table. Rescaling is required only for more than one input features. So you must know that suppose we need to rescale some of the columns having large values. So we cannot do like first column which we need to rescale, we are doing standardization. Next column we are applying normalization. We cannot do that. One thing only you need to do, either only normalization, only standardization. By seeing the data you have to understand that. Now see the normalization code. The ML library scikit-learn has a min-max scalar class for normalization. From sklearn.preprocessing import min-max scalar. So we are defining an object mms equals to min max scalar, and xtrain normalized equals to mms dot fit transform x of training data, and xtest normalized equal to mms dot transform xtest. So this is the code by which you can implement normalization. How to do this in a data, I will show it in my next video. You can try it out in your IDE, right? You can take a data, you can write a CSV file, and then from the CSV file you can just try to apply this standardization and normalization. In next video I'm anyways going to show that. So yeah, that's all from this video.